Hi everyone, thanks for coming. It's my first time in Lisbon today, so it's a great pleasure to be with you today. So I'm glad to speak about Core Web Vitals today and to give you some tips and tricks about optimizing them. So first of all, let me introduce myself. My name is Nicolas Frizzarin. I'm a Google developer expert in web technologies and Angular, also an OpenJS Foundation member. And I work as the developer advocate and senior staff engineer at Sphere Luxembourg. So what's the plan for today? First, we will see why your users are unhappy to use your application. Then we will see what really are Core Web Vitals. And finally, to focus on each metrics that compose the Core Web Vitals, so the LCP metric, CLS metric, and the last one, INP metrics, which will replace the FID metrics in 2024. So before beginning this talk, I suppose you guessed it, but this talk is about web performance, and more specifically about web performance that have a negative impact on the user experience. So first of all, I have some questions to ask. So raise your hand if you already have an application that takes too much time to render something, that results that you have a blinking blank screen when you launch your application. Okay. Second question, raise your hand if you already have a blinking screen in your application, like a Christmas tree. No? Okay. And the last question is, raise your hand if some of your users said your application is totally buggy because when they interact with the page, nothing happened. Okay. So, why users are unsatisfied while they use your application? So imagine all your integration test pass, all your unit test pass. So the business say to you, okay, your application is beautiful, let's go deploy it in production. And finally, your application don't use your application. So generally, users said, hey, sorry, but when I launch your application, it takes too much time to render something, or it takes too much time before I see something in the screen. Other users said, sorry, but I have a blinking screen. Some elements of your page pops on the screen in a randomly way. And final user says, when I click on a button or something like this, it takes too much time before the action show me the result of my action. So based on this information, we can identify three important information. The first one is the low speed. So the page takes too much time to render something. You have a blinking screen because some elements of your page are loaded in an asynchronous way and then pop on the screen. And finally, action takes too much time. So it seems that our application delivers a bad user experience, but improving the user experience is very hard, okay? And the only way we find to improve the user experience is to materialize this kind of problem as a performance problems, okay? And other things, it's a bad idea. Just imagine to create an application, deploy it in production, and wait the feedback of your users. So you have to improve the user experience during the process of the development of your application. So we must find a way to help developers to catch these issues and easier and earlier. And finally, web performance is very, very large. There is a lot of problem with performance, right? So we have to group metrics under a specific name that represents the user experience. What is important to understand in this talk is today it's really important to improve the user experience because the competition is big. Okay, you are not in the market and in the business. You are not the only one that create an application. So let's take an example. Easy. I'm sure in this room, all people have Spotify or maybe YouTube Music or Apple Music. Okay, if you don't like Spotify, it's easy to go to the competitor. It just unsubscribe to your subscription and it's finished, it's done. So if your application is not correctly made, maybe you will lose some money to your enterprise. So what really are Core Web Vitals? In 2020, Google announced to have the volunteer to integrate 3 new metrics into all their audit tools and dev tools. And in 2021, Google announced to integrated all the user experience under the name of Core Web Vitals in all their audit tools and dev tools. So Core Web Vitals is an awesome Google initiative that represents the user experience. And today, it's really important to respect the Core Web Vitals because Core Web Vitals have an impact on the indexation of your application in the Google search engine. So in other words, an application that respects the Core Web Vitals, the metrics of Core Web Vitals, will have a better index of than an application that doesn't respect the Core Web Vitals metrics. So to summarize, Core Web Vitals is an initiative from Google that aims to have metrics on performance of web application that represents the user experience. So, in the previous slide, we identified 3 important information. Now, these important information have impacts on the following metrics. So remember, the application we have takes too much time to render something on the screen. So this have an impact on the largest contentful panes metric. Then, remember, we have a blinking screen because some iframe or image pop in a randomly way in your screen. So this have an impact on the Cumule layout shift metric. And finally, when the user interacts with the page, the result of this interaction is too slow, and this have a huge impact on the last metrics, INP, interactive to next page. So now we know what really are Core Web Vitals, but what we don't know is how to calculate them. So we have 2 ways to calculate the Core Web Vitals metrics. The first one is by the field. So by the field is a real user monitoring, to be honest. So it lets you to retrieve real user data, real user metrics of the use of your application. And all the data collected by these tools are called field data. But as I said, we must find a way to help developers to catch these performance issues earlier and easier during the process of the development, right? And for that, it exists other tools called by labs tools. Labs tools provide data on how potential users may experience your website, d'accord? And generally, these tools provide labs data, and they are here to help you to debug your application, okay? Not debugging JavaScript, just debugging performance. So field tools, it exists a lot of field tools. This is Chrome field tools, so Chrome User Experience Report, Patch Speed Inside, Search Console, and Core Web Vitals extension. All these tools can calculate the LCP, CLS, and INP metrics. I know some people maybe in this room used Datadog, right? But you can continue to use it because these tools can calculate also the LCP, CLS, and INP metrics. It exists also a JavaScript library called webvitals.js. And this library gives you 4 helper functions to help you to retrieve easily the metrics and give you the possibility, thanks to a callback systems, to do what you want with the data collected. So maybe you want to send them in your own database to make some statistic after, I don't know. But this library is created for that. If you want to debug some Core Web Vitals metrics, of course, you can use Chrome DevTools and Lighthouse, but these tools can only calculate the LCP and the CLS metrics. Is anyone understand why these tools can't calculate the INP metric? Yes?
Because they cannot simulate like user behavior, because question was about the last metric.
Yeah, yeah. So yeah, it's okay. It's the correct answer.
The last metric is the interaction.
Yeah.
What users should do.
Yeah, this is correct. So unfortunately, lab tools can calculate the INP metrics because the user have to interact with the page, and emulate the user interaction is very complicated. It's also the same for the deprecating matrix first input DLI. Okay, they can calculate. So what is important also to understand is that lab tools and field tools are browser. They are not in competition. Okay, they need each other because the user experience depends on 3 important criteria. The first one is the user device capabilities. So now more devices are more powerful, right? So more your device is powerful, more the page is rendered faster. Okay? Then network condition is also important because now we create generally a client-side application. What is client-side application? Client-side application is an application that is entirely built on the clients. So all the navigation, data fetching, templating are handled on the clients rather than on the server. So initially, the browser will download all the JavaScript, all the HTML, all the CSS. So now imagine you have no networks. What is the result of that is the page will take too much time to be rendered. And if you have a very, very bad network condition, maybe what will happen is that the browser cancelled the downloading. So finally, your application will never appear for the users. And the last criteria is the kind of interaction. So I'm sure in this room you have all a mobile phone, right? But generally, when you use a mobile, you open an application and you never close it. You let live this application on the background. So at this moment, exactly what happened, the CPU will allocate a part of its processor for each application that run on the background. So imagine now, if you have a mobile with no application running on the background, when you launch your application, all the power of the CPU will be allocated at this application. That's why with a lot of mobile, with a lot of applications that run in the background, the page can be displayed more slower than on a device that have no application running on the background. So let's go now on each metrics. That's the most important part of this talk. The LCP metrics. So the LCP metrics represents the time that takes the browser to render the biggest block text or an images in your page. Okay? So if your score is less than 2.5 seconds, your score is good. Between 2.5 seconds and 4 seconds, your score needs improvements. And above 4 seconds, your score is very bad. Okay? And at this moment, you have critical problems. Problems in your application, but potentially problems on the server side. So LCP is quite complicated. So where to start when you want to debug an LCP problems? So as I said, generally we create client-side rendering application. So I repeat, the browsers will download the first index HTML file, the initial HTML document, and then in this document we have a lot of third-party scripts, your script, CSS style, images, and the browser have to download them in also. So the question is, when you find your initial HTML document, is what does this document need for initial load? Okay? And if your documents have dependencies, you have to identify these dependencies. What is LCP resources? Generally is image, fonts, something like this. And how these resources are loaded, and what is the size of these external resources. Other question is, are these resources necessary when the app starts? This is the main question. Currently, we are in an area of, we can just say, download what you want when you need it. That's the most important part of client-side rendering. So LCP problem is a very complex problem, and as all complex problem, it's a good idea to split it in smaller and simpler problems. The first one is the time to first byte. Time to first byte represents the time that takes the browser to retrieve the first bytes of the initial HTML documents. So this is a problem on the server side, and generally on a scale time, it represents 40%. Then we have the resource load delay problem. This problem is the time that takes the browser to download the whole initial HTML document file and your style sheet. And on a scale time, it represents 10%. Resource load time corresponds to the times that takes the browser to download all your LCP resources. Okay? And on a scale time, it represents 10%. And finally, we have element render delay. Element render delay is the time that takes the browser to execute, parse all your JavaScript and display the biggest block text or the image on your screen. Okay? So I think a schema is always better than a long explanation. So in this schema, in light blue, this is the time to first byte problems. Okay? It's the time that takes the browser to retrieve the HTML. Then in resource load delay, we can see that it's the time that takes the browser to download all the index HTML file and the style sheets in parallel. The resource load time arrives just after the resource load delay, and this is the time that the browser takes to retrieve all the LCP resources and also begin to download all the JavaScript and parse it and execute it. And finally, when all JavaScript is parsed and executed, you retrieve the LCP score. So it's a long time, to be honest. So if you want to improve the LCP problems, don't improve just one small problems. We have to improve all the problems. So we have to improve resource load delay, resource load time, and element render delay. Time to first byte is on backend side, so no problems. Element render delay is purely JavaScript. Okay, so what we need, the tips I will give you, is just for resource load delay and resource load time, because if you improve that, finally, you have an impact on the element render delay. So the goal to improve the LCP score is just to parallelize the downloading of LCP resources and style sheets, okay? And also, the goal is to begin the downloading of your style sheets earlier. So how to do that? First, preload your resource like style sheet. It's very easy. I'm sure you already know the balise, and the balise is, the HTML tag, is link. Who use link for linking style sheets in our page? Yes, everybody. So instead of just using link, href, real style sheet, okay? No, do just link, real preload as style sheet, href, and it will work out of the box. So it's quite easy to change. Then defer your script, lazy load all your script. Maybe some of your scripts don't need to be here or immediately here when you launch your application. So for that, use the async and defer attributes. You can use both on the same elements. So it's okay. Then in Chrome 1.03, it appears a new HTML attribute, which is fetch priority. And this attribute gives you the possibility to give a priority for downloading your resource. And the possibilities are quite easy. It's high, slow, medium. So quite easy. And finally, split your contents. This is the biggest part and the more difficult part, because splitting contents is always complicated. Just who use in this room Angular material? Yeah. And generally, Angular material, you link all the Angular material style. Okay? But maybe when you launch your application, all the Angular material style is not needed. Who use Bootstrap? Yeah, that's the same. That's the same. And also, imagine don't download a big library like Lodash or Moments. Use lightweight library. And if you want to use Lodash, use Lodash ES module. It will be simpler. So if you do that, now we optimize the resource load time and the resource load delay problems, okay? Because now when the browser discovers that your initial HTML documents have stylesheet dependencies, he begins immediately to download them. And in parallel, he will download the LCP resource. Okay? At this moment, you optimize the LCP score. So if you want to debug an LCP problems, you can use the first panel is performance to use, but I'm not sure if this panel is very easy to use because there is a lot of noise in this panel, to be honest. So if you don't use every day, it's complicated to use just for debugging something. So I recommend you to use the performance insight panel. This is a new panel, an experimental panel of Chrome, and it gives you more, there is less noise in this panel, just focus on the core web vitals, and it gives you some links to the official documentation to solve your issues. If you want to understand how to split your contents, the coverage tool panel will be your best friend. I just put an images to explain how it works. So this is all the resources that my application needs when it starts. In the blue parts, this is the part that is used of the document, and red part is the part that is unused. So the goal is to have more blue than red. Okay, and the final goal is to have just blue, no red. But that's very complicated. That's true. So let's go to the Cumule layout shift matrix. So Cumule layout shift matrix measures the instability of your screen. Okay, that's just that. So if the score is less than 0.1 seconds, your score is good. Between 0.1 second and 0.25 seconds, your score needs improvements, but don't worry. Maybe it's just images that are not sizing correctly, so it's not bad. But if you are above 0.25 seconds, the score is very bad, and at this moment you have huge problems. Maybe you have to re-architecture all your page, unfortunately. So what can cause a Cumule layout shift problem? Image with no size or with no good ratio size. Dynamically injected contents, that's important because we overuse of that. If you use Angular or Vue or React, we use ngIf or @if with a new code flow, something like that. So you hide or show elements from a condition and you inject, remove of the DOM. So that's if you have a large DOM, this can cause cumulative problem. Waiting network before update DOM, that's also another problem. So for that, go to IO talks and you can use server-side rendering with Quick to avoid this problem. Add embed iframe can also cause Cumule layout shift because they pop on the screen. And finally, recently, web fonts. Web fonts, because fonts are not equal. It's not because you have Roboto on font size 12 and Times New Romans on font size 12 that the two fonts are displayed the same. Okay? So in this video, you can see how iframe can have an impact on the Cumule layout shift. So something will pop on the screen, and unfortunately, the user will lose his reading focus because when the iframe pop on the top, the content shift downwards. So at this moment, the user loses his reading focus. So my tips to improve the Cumule layout shift is size. Size correctly your image with attributes or property CSS. Now we have a new property CSS called aspect ratio that lets you to give you a ratio between height and width for an element. Reserve for add embed iframes that have a static space. Reserve the static space in a placeholder for the page. At this moment, the browser will know that something will pop at this moment in this space, and then calculate automatically the page, the size of the page. For add embed iframes that are a high dynamic, please don't use it on the top. Place it on the bottom, right, left, where you want in the page, but not on the top. And finally, size your fonts. There is a new property called font size adjust, and this property lets you to size the fonts in rapport of another one. So that's a nice property. How to debug a cumulative problem? Quite easy. Go to Lighthouse. Just a quick few words about Lighthouse. Lighthouse is an audit a dev tool that can easily audit your code. You can use it in your CI/CD pipeline. And now in Chrome 1.03, there is 2 new modes. So now Lighthouse have navigation mode, which is just a report, an audit on the full reload of your page. You have a time span mode, which is just an audit between a moment of life of your page, generally containing interaction, and snapshot, which is a report at a specific time of the living of your page, generally after user interaction. So just a few words about FID metrics, even if it will be deprecated and will be replaced in 2024. So FID, what is FID? FID represents the times that takes the browser to just to call the event handler of an interaction for one interaction, not for all interaction in the page. Okay? So FID, if you are under 100 milliseconds, your score is good. Between 100 milliseconds and 300 milliseconds, your score needs improvements. And above 300 milliseconds, your score is bad. Unfortunately, if the score is bad, you can review all your JavaScript. That's not funny, I know, but you have to do it. So what can cause FID problems? It will be the same for the INP metrics, to be honest. The main thread blocked. So as you know, in JavaScript, we have just one thread. So with one thread, how can we create asynchronous code? It's easy. We created the event loop. Okay? So the goal to avoid the main thread blocked is to delegate to another block of the event loop, generally in the callback block. And use less JavaScript. I know when you create projects, we are in a hurry, we remove code or we comment code, something like this. If you don't use code, remove it. Because when the browser downloads the JavaScript code, even if the code is not executed, it is interpreted. Okay? So that's quite easy. Use your IDE and remove all the code that is in gray, light gray, normally. Tips to improve? Split JavaScript, avoid long task, so break it. Lazy load, use what give you all the frameworks now. Lazy load your components thanks to navigation and thanks to OS module. Now it's quite easy to just lazy load some piece of your code. Optimize network requests, avoid waterfall fetch requests. Okay, create promise all or promise trace. I don't know, depends on your needs, but try to parallelize network requests. And finally, if you have huge business on the client side, please delegate to a web worker, okay, to avoid blocking the main thread. So now the future of the Core Web Vitals INP, interaction to next panes. So what is interaction to next panes? Interaction to next panes represents the time that takes the browser to execute the event handler of an interaction and display the next render the next paint to the users for the whole interaction on the page, not just for one. Okay, so to compare, FID is just calling the event handler, but INP is calling, executing, and showing the results. Okay, that's the difference. So INP metrics score is good if it's 100 to 200 milliseconds, needs improvements between 200 milliseconds and 500 milliseconds, and bad if it's above 500 milliseconds. So before improving INP metrics, what is important to know is what is an interaction. Okay, it's true for all of us, interaction is when we click on a button and it's finished, but it's not exactly the case in web performance. In interaction, depends on 3 things. The first one is the input delay. The input delay is the time that takes the browser to just call the event handler. Okay, nothing is executed at this moment. Second thing is the processing time. The processing time is it's the time that takes the browser to execute the event handler. And the presentation delay is a time that takes the browser to paint the next frame. Okay, so after all the event handler code is executed. A new schema, I think it's better than a long speech. So imagine now you have a lot of interaction in your page. User interact a lot in the page, a lot of interaction are begin, but some interaction are very long. So at this moment, you have a blocking task, okay? And then the user click on the other button. Because the main thread is blocked, because there is a blocking task, the input delay will be long, okay? Between the user click and the browser called the event handler of this interaction. Then all the code is executed. So this is the processing time. And when all the code is finished and it retrieves the results, it paints something and renders something. So at this moment, this is the presentation delay. So what kind of interaction you can have? It's click, mouse, and keyboard events. Okay, but an hover an element is not an interaction. Sorry. So how to improve INP? First, minimize input delay. How to minimize input delay? It's quite easy. First, avoid long task. Okay. Avoid too much timer. What is avoiding too much timer? It's just avoiding to use set interval in all your code. Okay. And yeah, take care of interaction overlap. So create a page, but when you create a page, avoid to have a lot of interaction in it that you can do in parallel because it's complicated to manage. Then, as I said, avoid long task. But if you have a long task, you have to break up long task. So how to break up long task? First, defer code execution. Okay, create yield points manually. Yield only when it's necessary. Like if you have no task in the queue, it's not necessary to yield something. Okay, and finally, use a new developer preview API called post-task. You can use scheduler.postTask with something. And finally, avoid big DOM. That's quite complicated also, but yeah, you can use CSS property content to avoid that content visible. This will avoid big DOM. Finally, I will give you a little example. So imagine you have forms and you want to, this forms is for saving the settings of your users. And in this save setting, you have several methods. So first validate the form, then show spinner, save data to database, update the UI when you have the result of your saving, and send analytics to the backend. So when you see that, all these methods are not necessary immediately, right? Like save to database or send analytics, okay, save it, and it's okay. We can have the results after, but if you don't do anything with these results, it's necessary to do it on the main thread. So at this moment, you can just defer lazy works and make a focus on the critical work. So the critical work here is validate form, show spinner, and update UI. But save to database and send analytics can be done in other tasks. So how we can do that? It's quite easy. Just use a set timeout and with 0, okay? Just to delegate to the callbacks blocks of the event loop, to be honest, okay? And yeah, at this moment, the main thread is not blocked because it will continue in his life in the event loop. And when you go back to the callback blocks, the save database and the send analytics will be called, okay? If you use Angular, because I am Angular too, it's quite easy to optimize, to break up long tasks, because set timeout can be done with a subscriber. The only things we have to understand is that we have to manage errors correctly, because we will show directly something to the screen to the users, but if the call of HTTP call failed, we have to go back to the previous states of the application. Thank you. You can follow me on LinkedIn with Nicolas Frizzarin or Twitter @Nikos54. And if you have question, it's time to ask your question.
Okay, so my question is more related to the enterprise applications. Like, they don't care much about core web vitals, but how does like Google search impacts them? Do you think like they're related? I mean, they should focus more on core web vitals, and how they should do it?
Yeah. Currently, Google is a big work on their side. They are very focused on the core web vitals, because now core web vitals are totally integrated in the indexation of your application. So you have to be focused on like accessibility. For me, you have to be focused on that when you create your application, even if you create an application just for your enterprise. Because maybe, when you create something for your enterprise, at a moment, a guy says, I have a brilliant idea. We will have the same application for all our users. And at this moment, I think, when you create an application, we have to focus on core web vitals metrics.
But do you think Chrome really cares about it? Because if you see, just go to the Google and search for Netlify. The first result we get is Vercel, which takes 30 seconds to load.
Yeah. That's true. That's true.
Okay. So if I, as an enterprise, I can just pay more money and get my result on top. Like, I don't have to worry about core web vitals. To be frank.
Yeah, that's true. That's true. Chrome is have to integrate core web vitals on their own. Yeah, because there are some quite problems sometimes. That's true.
Hi. Do you have any? Can you give me some reasons that I can convince my boss that yesterday was the best day to handle the performance of the website, instead of doing all the stuff and later look and, our page is really slow, now we need to work on that. I know on the beginning is always the best, but we cannot sell it to our bosses usually.
Yeah. Some reason to convince your boss to optimize the core web vitals, right? Yeah, so the main reason is money. Because honestly, when you create an application for your company, and your company creates an application because they know this application brings them money, right? So now if you tell to your boss, hey boss, currently I know guys which do the same application as ours, okay? But the application is 10 times faster than ours. Your boss says in his mind, it will say, I will lose money. I will become poor. So honestly, he will say, let's go to performance. Because all parts of people, there is a lot of people that are not like me. I don't like waiting something. So when the page takes too much time to be rendered, I switch to another page, or I retry, or I go to a competitor. And honestly, that will become the real life for the whole application that we create every day. So yeah, money is the main criteria.
It's not a question, but I just want to add that it's really funny. You get the same questions as I get as an accessibility expert, like how to convince your boss, how to do this or that. It's
but
really,
the answer was not the same.
Yeah, the answer is not the same, and your answer is including money. In my case, it doesn't relate it to money, so I can't use this idea that we'll get more money from our users in case we do accessibility. Of course, we'll get more money, but not that big amount.
Not big. Yeah.
Visual, yeah.
That's
so
true.
that's
true.
pretty interesting.
At your work, at your last projects, yes, your company, they like allow you to spend time on all these performance things, or you just deliver features and fixing bugs?
Yeah, that's true. So I'm consulting. So currently, I worked for as an architect for a Lombard international company, and in my team, we are two, and Lombard said, "Do what you want." So honestly, I can improve the performance, and I spent my whole week last week. I deliver no feature. For example, I migrate all the application in Angular 7, and the next week I think I will spend some my week to improve some performance of another application. So no feature, but when my boss says to me, "Now it's time to deliver," okay, I will cut the night to deliver the feature.
Cool, thank you.
You're welcome.
Any other questions? Okay, thank you very much.
Thank you too.